Okay, so let's look at chapter 7 in 105. That's the muscular system. So let's first off looking at types and functions of muscles. So let's look at types of muscle tissue. So this picture shows the 3 types of muscle tissue. So skeletal, cardiac, and then smooth muscle. All right. So this is one of the things that we skipped in the muscular, or back in chapter 4 when we were talking about tissues. I said I was going to talk about the tissues later on. So looking at skeletal muscle tissue. So this is a type of voluntary muscle tissue in muscles attached to bone. Now, one of the things that we see with skeletal muscle is it has these alternating dark and light lines, and those alternating dark and light lines are known as striations. Okay. These cells are multinucleated. It's hard to see in that picture, but you can see it here. So these cells have more than one nucleus. So what happens in development is we have a lot of cells there that fuse together to create this longer, so one cell that's really long. All right. Now, the thing about skeletal muscle tissue is that it needs nerve stimulation to contract. So in order for me to contract these muscles in my arms and my shoulder, is I have to send a nerve impulse out to those muscles to get them to contract. So one of the ways that we can look at skeletal muscle tissue is to call it striated voluntary muscle. So it has striations in it, it's voluntary. I have to consciously think about contracting that muscle for it to contract unless it's controlled by a reflex. Next is cardiac muscle tissue. So this is showing cardiac muscle tissue. This is specialized muscle tissue found only in the heart. Another way to call it is striated involuntary muscle. So it has striations, but it's involuntary. So we don't consciously think about it contracting in order for it to contract, which is a really good thing because your heart contracts anywhere from 60 to 100 times a minute. So, you know, if you had to think about that all the time, well, there's little else that you would do. All right. Now, our heart muscle cells do not need nerve stimulation to contract. All right. So, I don't need to send a signal out from my brain or spinal cord to get my heart to contract. It's going to contract on its own. But nerve activity can affect the rate. So if a bear were to come in here, right, that would activate, I would get scared, right, and my heart rate would go up. So that's a nerve impulse there that would cause my heart rate to go up. Now, if the bear stopped all of a sudden, took its head off, and hey, it's my buddy Steve, my heart rate would get back down normal, and that would also be by nerve stimulation. Okay. Now, one of the things that cardiac muscle does have is that it has these things called intercalated discs. So you see these darker areas. Those intercalated discs are specialized regions of connections between cardiac muscle cells. They contain desmosomes and gap junctions. And by having gap junctions, that allows the cytoplasm from these cells to be interchanged. Okay. So heart muscle cells also branch, so they connect to several cells. So by having these intercalated discs and these branches, this helps channel the forces of the contractions, and I'll talk about that a little bit later. Okay, next is smooth muscle tissue. Smooth muscle tissue is a type of involuntary muscle tissue in the walls of hollow viscera. Hollow viscera, hollow internal organs. So blood vessels, your stomach, your bladder, your large intestine, small intestine, that sort of stuff. It has no striations, as you can see, and so it's referred to as non-striated involuntary muscle because of that. It can contract on its own or by nerve cell activity. Okay, so let's look at the functions of muscle. One, muscle contractions produce heat. This is going to help maintain our body temperature, right? We know if we get cold, we're going to shiver, right? Skeletal muscle contractions produce movements. So muscle contractions in general produce movements. So skeletal muscle is going to produce body movements. Cardiac muscle is going to move blood. And smooth muscle, for the most part, moves substances when it contracts. So I'm saying mostly there. The iris of your eye, the colored portion of your eye is made of smooth muscle. So if you go into a dimly lit room, your pupils are going to dilate. So you're going to have some smooth muscle contraction. You're not moving substances there. So next, tendons of the muscles help to stabilize the joints. Muscle contractions also oppose the force of gravity. This allows us to remain upright. So if your muscles relax, you would just slump to the floor. And then also muscle contractions are used in communication. So not just verbal communication, but also nonverbal communication, body language, facial expressions, stuff like that. Okay, let's take a look at skeletal muscle structure. Now, a skeletal muscle is composed of skeletal muscle tissue, connective tissue, nervous tissue, and blood. All right. So if we look at, it's more than just skeletal muscle tissue. So if we look at connective tissue there, the connective tissue that surrounds muscles in our body is kind of collectively known as fascia. So this is a general term for connective tissue sheets within the body. So that includes like the fibrous stuff. It also includes adipose tissue. So let's look at types of connective tissue in a muscle. The first is the epimysium. So this right here is the epimysium. So this is connective tissue that closely surrounds a skeletal muscle. All right, goes completely around it. So it is made of dense, regular connective tissue. All right, and so this may form a tendon like what we see here. And tendons connect muscles to bone. All right, and so here, what's nice about that is that the epimysium here becomes the tendon, which then the tendon is continuous with the periosteum. So the periosteum is connective tissue that surrounds the bone. All right. So it may form a tendon like what we see here, or it may form what is known as an aponeurosis. So an aponeurosis is a sheet of connective tissue that attaches adjacent muscles. So you go from one muscle, so here our external oblique, to the other external oblique. Okay. All right, let's go back to our previous picture here. So the next type of connective tissue is called paramycin. And this is connective tissue that surrounds bundles of muscle fibers. So this is a bundle of muscle fiber. That paramycin surrounds that bundle. Now that bundle of muscle fibers, or group of muscle fibers, is known as a fasciculus. Okay? Fasciculi is plural, fasciculus is singular. Now, this is showing an individual muscle fiber out there. We also have connective tissues that surrounds that, and that is known as the endomysium. So this is connective tissue that surrounds individual muscle fibers. Now, a muscle fiber and a muscle cell are the same thing.